Hey folks, and welcome back. Today we're going to be taking a look at how do we do energy calculations for both kinetic energy and gravitational potential energy. Remember, we also briefly talked about thermal energy, but there's no calculations that we need to be able to do for that. So our first equation is our equation for kinetic energy, and that is Ke is equal to 1/2 times m, which stands for mass, and then we have v squared, which is velocity. Now, I mentioned this before, and I'll say it again. That square is only going to apply to the velocity. It does not apply to everything there. You need to make sure to square the velocity first before you do the rest, and we'll take a look at that. Then we have gravitational potential energy is equal to m, which is still mass. We have g, which is gravity, and remember that gravity is a constant on Earth, which is going to be 9.8 meters per second squared. And then we have h, which is the height. And remember that gravitational potential energy is due to the height of an object, so that's why we're including height there, whereas kinetic energy is the energy of motion, so the faster an object is going, the more kinetic energy we're going to have. So let's take a look at number one. In number one, we have a 250 kilogram rock, which is on the edge of a 40-meter cliff. How much gravitational potential energy does it have? So gravitational potential energy means we're using our GPE equation, so GPE is equal to m, g, and h. Now, we need to go through our problem and identify the information that were given to us. So a 250 kilogram, so kilograms, that's going to be a mass, is on the edge of a 40-meter, right? Remember, meters measures height. So we are given the mass and the height, and you're probably like, okay, well, what's g? Well, again, remember that g is a constant. G will always be 9.8 for every single problem that you do. So GPE is equal to the mass, which is 250, times gravity, 9.8, times the height, which is 40. So we have 250 times 9.8 times 40. So get out a calculator if you need to be able to do that, which I certainly do. So that's 250 times 9.8 times 40. And so that is going to give you 98,000 joules. And what you will find is that energies tend to be fairly high. Okay, so don't be afraid of getting large numbers. Energies will typically be pretty high numbers. All right. Okay, so that's how we do our gravitational potential energy equation. The main thing to remember here is that G is always 9.8. So you're only going to really be given two numbers in the problem. And so you just need to recognize which of those are the mass and the height. For number two, we are finding, we have a scenario where we have a 500 kilogram rocket is moving at 150 meters per second. And notice that we're moving, so that is going to be us figuring out how much kinetic energy does it have. So again, kinetic energy is equal to 1/2 mv squared. Okay, now we need to go through and identify the information we're given. So a 500 kilogram rocket, so 500 kilograms, that is going to be our mass, and then it's moving at 150 meters per second. That is going to be our velocity. So let's go in and put that information in. Ke equals 1/2 times the mass, which is 500, and then that is times the velocity, which is going to be squared. Now, let's remember our order of operations. Remember, we've got PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. So we need to make sure that we are taking care of our exponents first before we get to multiplying. And that's why I was mentioning that we need to square the velocity first, right? So we need to make sure that we do the squaring the velocity first. So what we have now is that Ke is going to be, oops, E, not just an equal sign, is equal to 1/2 times 500. And then we're going to multiply that by the 150 that is squared. So let's make sure we do that first. So 150 squared gives us 22,500. Okay, again, notice we got some pretty big numbers. And then we just need to multiply all these together. So Ke is going to be equal to that 22,500 times 500 times half. You can put that in as 0.5 in your calculator. So that gives us 505,625,000. And then again, this is still energy, so our unit is going to be joules. So just make sure that you do those steps properly, and you will make all of your calculations good. Now, that is going to give you some examples for how you're going to be answering questions 1 through 6. Question number 7 is a little bit different, okay? And the rest of those are a little different. Here we have a scenario where we have a skater who has a mass of 50 kilograms. So there's the mass. And it shows his energy at different locations. Notice that it also shows you the height, okay? So the heights are given to you as well. And so what we can see is 5 different locations, A, B, C, D, and E. So the first question says, how much total energy does Li Ping have at point A? So at point A, we have 0 joules of kinetic energy and 50,000 joules of potential energy. So how much total energy is that? Well, to find the total, you're just going to add those up, which of course is just going to give us 50,000 joules. 50,000 joules. All right, now, if we go down here to A, it says how much total energy will Li Ping have at every point? And what we need to remember is that the law of conservation of energy states that the total amount of energy does not change, right? Energy cannot be created or destroyed, all right? It's only changed between different forms. So by having 50,000 joules of energy at the top, of total energy at the top, we should expect to have 50,000 joules of energy at every single point along the way. So how much total energy will he have at every point? He's going to have 50,000 joules of energy. Now, let's do one more together. All right. If he has 50,000 joules of potential energy at point B, right, how much potential energy will he have? Well, notice that we are given that he has 20,000 joules of kinetic energy. All right. Again, the total needs to be 50,000. So to figure out the amount of potential energy we're going to have, right, we just need to figure out what the missing amount is, right? 50,000 is equal to 20,000, that's the kinetic energy, right? Plus the potential energy. That's what we don't know. How are we going to solve for potential energy? Well, we're just going to subtract 20,000 from both sides, right? We're just figuring out how much potential energy we have. And so if you take 50,000 and subtract 20,000, you will find that you have 30,000 joules of potential energy, okay? So that is how much potential energy you'll have here at point B. For the next question, it says at point C, Li Ping is 30 meters above the ground. Is that right? Yeah, 30 meters above the ground. So that is going to be your height. It asks you how much potential energy. So you need to calculate the potential energy using the same equations we did above. And then you need to use what we just kind of did in order to figure out how much kinetic energy he has, remembering that the total amount is going to be 50,000. You're just going to repeat that a couple times. It's going to ask you how much kinetic energy does Li Ping have at the end. Again, think about what the total amount of energy should be. And then finally, for your bonus, you figure out how fast Li Ping is going. Remember how fast, another way of saying that is velocity. So you're going to try to find the velocity there, all right? If you have questions, please reach out. Hope you have a wonderful day, and I will see you soon.